All right. Hello again, everyone. My name is Kimberly Colbert, and I will be hosting today's webinar. So good afternoon. We are pleased to welcome you to the Washington Labs Academy webinar series. We hope you find the next hour or so useful and informative. And now, I'd like to introduce our presenter. Stephen Koster is president at Washington Laboratories, Ltd. Steve has over 30 years of experience in testing systems and devices for regulatory compliance. His expertise spans a full range of product evaluation from IT, medical, machinery, measuring, and communications, including wireless. He has the Washington Laboratory team accomplishing all manner of product compliance evaluation. So, without further ado, let's turn our attention to RF exposure fundamentals with Steve. Hi, Steve. It is all yours. Take it away.
Thank you, Kim. Let me go ahead and share my screen. Good afternoon, everyone, and welcome to Washington Labs Academy. Today, we're doing a presentation on the fundamentals of RF exposure. We'll look at it from a very high level because, it's quite a complex topic. So we'll do what we can. We'll look at some rules, definitions, limits, touch on procedures, more about which procedures are used, things like that. We'll go ahead and start with some definitions. We're talking about RF exposure. So what is RF exposure? RF exposure means being exposed to RF radiation, radio frequency radiation, which is the non-ionizing type of radiation that includes radio waves and microwaves. Okay, so that brings up another one. What is non-ionizing radiation? Non-ionizing radiation is the kind of radiation in electromagnetic spectrum that does not have enough energy to remove an electron from an atom and turn it into an ion. And they use non-ionizing radiation to generate heat, and that's what they use in microwave ovens. And you can see how that would warm something up. What is specific absorption rate? Well, SAR is a measure of the rate at which energy is absorbed per unit mass by the human body when exposed to radio frequency electromagnetic fields. It's defined as the power absorbed per mass of tissue and has units of watts per kilogram. How much is a RF source going to warm your tissue? And then we'll look at maximum permissible exposure, or MPE. It's a limit of the radio frequency electromagnetic fields the general public can be exposed to safely. MPE is based on the SAR requirements. Okay, let's look at the different exposure environments we have. This is right out of the rules. This is 47 CFR, Part 1. RF exposure has a couple of different environments. This is the occupation or controlled exposure. It can be 0.4 watts per kilogram averaged over the whole body, and a peak spatial averaging of 8 watts per kilogram over 1 gram of tissue. There's some exceptions to that. Your hands, wrists, feet, ankles, and pinnae. Peak spatial average is 20 watts. So that's the requirements in that particular type of environment. And then you also have the general population. Well, the general population is uncontrolled exposure. So it's a lower limit of 0.08 watts with a peak spatial of 1.6 watts per kilogram over the 1 gram of tissue. Again, you have extremities and things that are not subject to that. 4 watts per kilogram over 10 grams of tissue is the SAR limit, and the exposure is averaged not to exceed 30 minutes. So there's a lot of that information that is included there, but at a high level, we just basically have to make sure that we're not having any problems. All right, you go above 6 gigahertz, the MPE limits become in play and used to evaluate the environmental impact to human exposure. Reference level is like 1 milliwatt per centimeter squared. Portable devices assessment uses incident power density or absorbed power density, IPD or APD. And of course, a lot of this stuff comes out of the KDB publication 447498, different versions. This was out of DO4. RF exposure, maximum permissible exposure. They reference the levels, the level limits. They look at E field, H field, and power density. It's MPE. The limits are derived from the whole body SAR limits and allows the MPE limits to be used instead of whole body SAR, except for portable devices, as these evaluations have been performed according to SAR provisions. Portable devices, you're looking more, they're closer to the body, so therefore you have to actually do the tests. And the limits come out of a couple basic standards, the biological effects and exposure criteria of radio frequency electromagnetic fields from the NCRP. And ANSI has a standard C95.1 that has this information. Here's a table out of part 1 that shows the different requirements or different limits by frequency. As frequency changes, the limits do change as well as and you'll see that it's divided into occupational or controlled environments and general environments. You'll notice that, of course, obviously the general environments requirements are lower because, well, we'll look at that. So how can you become a controlled environment or occupational? What kind of things do you have to satisfy? Well, the persons that are exposed because of their employment, those persons they have to be fully aware of the potential for exposure. They can't just be walking around not understanding that. They have received written and or verbal information fully explaining the potential RF exposure results. They have to be trained. They receive appropriate training and work practices relating to how do you control or mitigate the exposure. And they have the ability to exercise control over their exposure. They're allowed and knows how to reduce or avoid exposure by administrative or engineering work practices, such as the use of protective equipment or time averaging of exposure. They may say, I can only be in that facility or that area for 5 minutes and have to leave. Some things like that. The general or the uncontrolled exposure is for the general population, and it's where the general public may be exposed. People who are exposed as a consequence of their employment may not be fully aware of the potential for exposure and cannot exercise control over their exposure. So they don't have the knowledge that they're being exposed or what the exposure will do to them. RF sources intended for consumer use, they need to use the limits for general population or uncontrolled exposure because they don't know where it's going to be. So all Part 15 transmitters have to apply the general population limits. because, unlicensed devices can go just about anywhere they want. And the PCS and UNI devices are subject to the limits of general population as well. A couple more definitions out of the rule book. Source-based time averaging. It's an average of the instantaneous exposure over a time averaging period that is based on inherent property or duty cycle of a device to ensure compliance. The time averaging period is the time period not to exceed 30 minutes for RF sources, or time period inherent from device transmission characteristics, not to exceed 30 minutes for mobile and portable RF sources. RF source is commission-regulated equipment that transmits or generates RF energy waves, whether intentionally or unintentionally, via one or more radiating structure. Multiple sources may exist in a single device, and that we can touch on that a little bit later. The radiating structure is an unshielded RF current carrying conductor that generates an RF reactive near electrical or magnetic field and or radiates an RF electromagnetic wave. It's a component of an RF source that transmits, generates, or radiates an RF field, antenna, aperture, or coil. So the radiating structure is where you determine your distances from. Antenna is another way to say that. That's just a couple of the definitions that are presented in that rule part. There certainly are more, but you can find them at paragraph 1.1310. Okay, then you have the different types of devices. Okay, so you have mobile, portable, mobile, and fixed. A mobile device is used such that the separation distance of at least 20 centimeters is normally maintained from the person, the body of the person. And a fixed device is physically secured in one location and not able to be easily moved to another location. And they do have routine evaluation exclusions from part of the rules just because of that distance. And that would be, then you would apply the MPE requirements or MPE test. Use of the device may not allow easy classification. So if your device is hard to determine whether it's mobile or portable, the FCC is going to say it's portable, because you need to make sure that you address the worst case. So worst case would be portable. And if there's any question, they will be happy to tell you it is. A portable device is designed to use that the radiating structure of the device is within 20 centimeters of the body. It includes routine evaluation exclusions. We'll look at those in a bit. General population or uncontrolled exposure limits apply to portable devices intended to be used by consumers, people who expose because of employment, and the people that may not be fully aware of exposure and have no control. No communication with the consumer, including either visual advisories or manual instructions, will be considered sufficient to allow the consumer portable device to be evaluated for the controlled exposure. Basically, you can't put a note in the manual that says you need to, this thing looks like it's a portable device and you'll use it that way, but don't, because the RF exposure will be not compliant. Portable devices that transmit at frequencies above 6 gigahertz, where there's not a lot of SAR equipment, evaluated in terms of MPE and IPD and APD. And they use the MPE limits, and you look at the separation distance to make sure that you evaluate them at the right distance, and a PAG or pre-approval guidance will be needed for those. Well, there are exemptions to routine evaluation. How can you be exempt? 3 separate criteria for exempting RF sources. One is that the output power is less than 1 milliwatt. 1 milliwatt is pretty much the upper level before you have to start doing routine evaluations. The power threshold based on frequency and distance from the device operating in the 300 megahertz to 6 gigahertz, and the separation distances of 5 millimeters to 40 centimeters from a person. There is a table in 447498 that shows at different frequencies and different distances what your threshold would be. And based on frequency. It's only an exemption from routine evaluation. You still have the obligation to comply with our RF exposure, and it remains subject to determination of whether there's no significant effect to the quality of the human environment. So you got to make sure that you're not exposing people to RF hazards. When new rules are introduced, major updates to the guidance were required, and a draft version of this KDB 447498 DO1 was released for comments, but they had quite a few questions. One, they included the emissions from unintentional radiators, and as a community, the labs are not really fully aware of how to include that. What does that look like? How do we apply exemptions? How do we handle devices below 300 megahertz and as portable devices at 0 millimeters or 5 millimeters? And so there was a lot of questions. So then they released an interim guidance, and you can use so they did a few clarifications, and the clarifications were in the introductory text. And then they came out with this notice, DO4 interim guidance can be used for equipment authorization and must be used in its entirety. The associated revised KDB RF exposure procedures and policies during a transition period from August 13th until further notice. When they end the transition period, there will be plenty of advance warning before that, is what they've said. You can still use the V06 during the transition period, but you've got to use these KDBs in their entirety. You can't use a piece from one of the KDBs and a piece from the other. You have to use all or none. So we're in a transition period until we're not sure. This is just more on the transition. Got to include equipment where you're claiming exemption. Contributions from an unintentional or intentional radiators are not required to be included in the assessment at this time. The exhibits illustrate how guidance in the applicable KDB has followed. As an explanation in the previous paragraph, by adhering to the guidance of one or the other, applicants must follow one of them. Can't mix and match. don't know if I can move this bar. No. RF exposure test exemptions provide a means to get certification without the need to show data, show any measurements or analytical numerical modeling to demonstrate compliance. The KDB notes that the RF exposure evaluation may be required when the potential for exposure cannot be easily determined based on exemptions. Again, you've got to make sure you cover the worst case. Applications, when you send them to the TCB, they have to address RF exposure. All transmitters have to address RF exposure. If you're looking for a exemption, you have to have justification for that exemption, or you need to do routine evaluation, the SAR tests, the MPEs, power density, APD, IPD, in accordance with the KDB for all non-exempt sources. Modeling analysis is allowed per that KDB, so you can do modeling and use that as your evaluation. All right. A few concepts that we need to remember is the assessment is based on maximum power across the production units. We do require that when we look at the maximum power, we also include factory tune-up. What is your tune-up procedure, and how do you set the power, and how much variation may you have in that? You compare that against the highest power against their thresholds for exemptions. Measured values need to be scaled to account for difference in output power of the device tested versus the maximum power. Sometimes it's a little difficult to get the power measurements exact. So if you have, if you believe the power is higher than what the measured power is, you still have to scale it up to that. The source-based average power is considered time averaging, where the time averaging is, controlled by the protocol. If you've got fixed talk or listen radio, they transmit only in specific time slots. You can use that timing source-based as to help assess your device. It cannot be based on how you expect to use it. Okay, people aren't going to use this device. When they use this device, they're only going to use it for 5 minutes an hour, or they're going to use it for 3 minutes a day. Those are not acceptable. But anytime you use a duty factor, it does require a PAG. And how are you going to be limited? Like tracking devices where they're pulled at intervals and limited data is sent, those types of things. E-readers, they download a book at one time and then they're not going to be used much after, the transmitter won't be used much after that. So you can work on those types of duty factors, but again, looks like they need a PAG or pre-approval guidance. Take a quick look at some of the standards. There actually was only one international standard that was at the FCC's measurement procedures site, and that was the IEEE 1528. As far as I can tell, the rest of the procedures are all called out in the KDBs. And KDBs some are general, some are technology specific. And if you look at some of the technology specific guidance, you'll see that talk about the technology. The 802.11 has a KDB. LTE has KDB. If you're going to do time averaging SAR, it has a requirement for pre-approval guidance. And the 6 gig Wi-Fi has KDB or 2. And also there is some information from the TCB workshop in October using source reconstruction methods, which is another way to show compliance. Other ones, 4G, 5G. And as you see, like dynamic antenna tuning, this doesn't necessarily have its own KDB, but it was presented at a workshop and subject to PAG for antenna tune. And then the other technology specific is carrier aggregation. Needs proof. And then there's product specific guidance. For example, dongle transmitters, there's a KDB and workshop information on your exposure condition, 5 millimeters from the body or whatever. Laptops and tablets, portable hotspots, UMPC, which ultra mini PC, the very small mini tablets, handsets with phablets, wireless charging covers that go on your phone, wireless charging power transfer as KDB, wristwatch. Wristwatch are fun, and different transmitters with low duty factor. I guess the point of all of this information is different devices have some guidance, either through KDB or through some of the FCC's presentations at the TCB Council or TCB training. And PAG is required for some of them, etc. So knowing your device and knowing where it falls in under the different requirements certainly is worth knowing at the beginning of your project. There's specific guidance for modules, 447, 498, and 616217. Module manufacturers can add specific hosts that are used close to the body to the scope of their grants by performing SAR evaluations for that host. You got to have the assessment and certification for each host, because depending upon the host geometry will determine how the SAR is tested, and if you move that module to another device, it may not still follow with that and will not comply. Alternative hosts allows manufacturer to perform SAR tests with the module and its antenna. If it exceeds a specified value, module may be limited to certain platforms. Test separation distance may further limit the hosts allowed, and SAR data is subject to the antenna used. It's a small change in an antenna can have a big change in SAR. And I don't deal as much with modules that have to have SAR, but I deal with the modules that have to have MPE, and you can't change the antennas. The antennas have to be what they were certified with. And then special cases, the host system controls the power for the module. They comply with RF exposure requirements through proximity sensing. That's a whole other category of how to make sure you comply with RF exposure. There's capacitive, or there's motion sensors that can turn the power down if they realize that you're closer to the device than you should be. They prefer to have a host certification. The option and do a change of ID and then follow a permissive change certification. And the permissive change would then have to address the RF exposure for the module in that host. A new ID can be obtained, but becomes that module host combination is locked in for that ID. It can't be used for other hosts. The host SAR test in general, separation distance is less than 5 millimeters. The SAR value is at 0.4 watts, which is going to be the worst case. They need to be approved for specific hosts or set of hosts. And you can add hosts with a class 2 change. You got to be less than 1.2 watts per kilogram. It requires a PAG for case-by-case consideration. Sorry, if the SAR value is greater than 1.2, you can still get certification, but it's going to have to get approval guidance. What if you have more than one transmitter in your device? The exemption threshold and measurement methods address individual RF sources. So you're looking at putting a Wi-Fi with a Bluetooth and maybe a LoRa radio or just different devices in there. Compliance of the devices must consider the aggregate effect of all the RF sources that operate simultaneously. If they're not simultaneous transmission, then it's not, you can still use the individual RF consideration, but if they work together, then yeah, you have to look at them all. 447498 lets you use the concept of total exposure ratio. Total exposure ratio is the ratio for each individual RF source. So you assess each source through routine evaluation, and then the ratio of the measured value to the applicable limit will tell you where that particular RF source is, how far it is under the limit. You add the different ratios, and as long as you're below 1, then you can state compliance. And if you're exempt, you still have to determine how far under the limit you are so that you can use the exempt threshold. So you look at the different thresholds, you get the ratio of where they are. They're 70% of the limit or 20% of the limit. You add those all up, and as long as you end up with less than 1 for all your simultaneous transmissions, you can use that information to show compliance. Yeah, I mean, that's just touching. Like I said, we're just doing a high level on RF exposure. It's just touching on a few things to know, where you can find the requirements, what the requirements might be, the definitions of the different environments, etc. In Canada, if you wanted to send your device to Canada, all those requirements come out of their safety code 6. Safety code 6 with notices, local exposure limits for radio frequency fields in the 6 gig to 300 gigahertz range. There's notice on that. Technical guide for safety code 6 is available. It helps you understand that. And as in the United States, it does apply to all transmitters. All transmitters, even if they're exempt, you have to address the exposure requirement. You still have to have an exposure exhibit. Okay, back in RSS 102 issue 5, covered all transmitters, and in notice 2020-020 updated the normative test standard for the SAR to the IEC IEEE 62209. It used to be 62209-1 and -2. They've combined those into 62209-1528. And there's several supplemental procedures on RF exposure KDBs. So they do use some of the KDBs that the US used from the US. RSS 102 issue 6 is a major overhaul in the layout, document structure. It's going to replace the RSS 102 supplemental procedures with the RS 102 plus the RSS 102 dot either ns.meas or etc. They've got several of them. It's going to be a 12-month transition period from issue 5 to issue 6. Looked like they actually published the issue 6 December. So you have until December of this year you can still use issue 5, but issue 6 will be in effect then. And equipment does not need to be recertified if it was approved to issue 5, but they expected to comply with the latest version after the transition period. And that's the way they deal with most of their RSS upgrades and standards. So in issue 5, we had the SPR 002, which was for nerve stimulation. SPR 001 bystander SAR, which was an interesting concept. Time average SAR, absorbed power, etc. These were all the SPRs that were involved with issue 5. And now issue 6, they have these companion standards. ns.mes is nerve stimulation measurements. Again, they're all pretty explanatory by their title. SAR.mes is SAR measurements, all the way down to FRL, which is field reference level, or MPE. SAR limits, they are different, or even either they're slightly more stringent than the US, or they have different definitions for their limbs and extremities, for example. The MPE limits are not equal to the FCC. MPE limits are watts per meter squared. 1 watt per meter squared is equal to 0.1 milliwatt per centimeter squared. So that conversion, we do milliwatts per centimeter squared in the US, and they do watts per meter squared in Canada. IPD and APD limits, a spatial average power density of 20 watts per meter squared over 4 centimeters squared, chunk of 4 centimeters, and above 30 gigahertz, there's additional requirements. It's got to be less than that. Nerve stimulation, basic restriction is internal electric fields with the limit of 2.7 times 10 to the negative fourth in frequency measured via via computational analysis. E&H field reference levels are derived from internal electric fields. Nerve stimulation is required for devices below 10 megahertz. And we do not have that requirement here in the United States, but it is something that they do in Europe or in Canada, and been working with that for years. Now this table just shows the difference, the RF exposure limits, MPE limits between US and Canada. Look at the table for your frequency range, and you get an idea of where you're at with the requirements for the FCC as opposed to Canada. The exemption thresholds are derived for devices used within 20 centimeters of user can be found in section 6.3. Table, it's got the power values at various frequencies and separation distance for the body and head exposure. There's a linear interpolation between those frequencies and power levels. And if you're looking for limb-worn devices, you can multiply that value. So based on separation distance, the maximum conducted power and EIRP are not equal to the FCC SAR exclusion thresholds. They are typically lower. And if power exceeds the threshold, SAR measurements or computational assessment is required. These would be for portable devices. If you're not exempt, you have to do the test. Simultaneous transmission, again, you got to be under the thresholds. Portable devices above 6 gigahertz basically have to be below 1 milliwatt. And that's really been targeted toward UWB transmitters. A lot of the other transmitters in that frequency range are going to be higher, they may be higher than that. And issue 6 is the new draft for issue 6. Issue 6 proposes a threshold from APD based on frequency and separation distance and a 1 milliwatt exemption. So a 1 milliwatt exemption is pretty much across the board. Mobile and fixed devices, exemption threshold of greater than 20 centimeters from the users. Of course, it's again based on power. When EIRP threshold for exclusion from routine evaluation, you can do calculations or measurements. You can use simple calculations based on the Freeze formula. Threshold power levels give values at the limit of 20 centimeters. A lot of times, if the ERP exceeds, the FCC requires measurements if it exceeds the FCC threshold as well. So, yeah, you normally, if you're doing MPE, they look at 20 centimeters. They don't care that your device complies at 4 centimeters or 6 centimeters. It's just basically, it's a mobile device and you're not supposed to be within 20 centimeters. So they want all of that done at 10 centimeters. But there is a requirement for tabletop devices to where you need to do them at 10 centimeters. You still look at the reference level and measure the ENH field or power density, calculate it through the formula, so you can still be exempt, but it'd be a different distance. Nerve stimulation is a phenomena below 10 megahertz. It's an instantaneous effect. There's no time averaging for nerve stimulation. SPR2 issue 2 is in effect. That tells you how to do that test. And normally, the distance is less than it is for SAR and our MPE. Issue 5 had no exemptions for nerve stimulation. So you would do nerve stimulation for devices under 10 megahertz, full stop. There's no exemptions, so you have to do the test. Incidentally, you have to have a incidental close proximity device to be able to do the evaluation. And because you might end up being real close to the device, for example, a wireless power charger, as you put things on, take things off of that charger, you're going to be in real close proximity. So simulation assessment often requires an assessment because SPR has some stringent requirements from the measurement probe size. If you have a device and you, for example, don't have the right measurement probe, then you have to do a simulation in order to show compliance, and that appears to be acceptable. Now, issue 6 draft proposes an exemption for nerve stimulation, but it's based on coil size, current, number of turns in the inductive system. But if you've got a capacitive coupled system, it still have nerve stimulation requirements. It cannot be exempt. The RSS 102 modified, and they use the 62209 since May, and limited the frequency range 4 megahertz to 6 gigahertz. Above 6 gigahertz, you use the power density, same as US. They do use some of the United States KDBs, for example, KDB 941225 for LTE devices. Then they're talking about SPR 004 takes precedence for time averaging SAR assessments because 004 is a time averaging device. There is an IEC 62209-3, which uses vector-based systems, but that standard has not been adopted by Canada or the US. You can do the fast SAR, but it's only to identify worst case. You cannot use the fast SAR as to show full compliance with your device. And then once you determine the worst case, then full SAR is required on that particular mode. And they're using C95.3 for the MPE requirements. They do have a list of all the acceptable KDBs that they use from the US. They're here, they're listed here. And exemptions and thresholds. Exemptions, for example, the thresholds determine exclusions cannot be used because they don't match. I mean, you can, the thresholds are different. The exemption thresholds are different for US and Canada, so can't use the United States exemption power to show compliance with Canada, which kind of makes sense. That was a quick run through. I mean, it's about 45 minutes worth of information for just a high level look at different requirements for the exposure in the US and Canada, because yeah, you can't do too much in an hour. When we sat and did 2 days worth of RF exposure for when we were at the TCB training in October. So yeah, I can't dig into it too deep, but that was just a quick overview. They do have RF exposure requirements in Europe as well. Of course, that falls under Article 3.1a of the Radio Equipment Directive, which is a safety requirement. The device has to be safe, and it's not just electrical safety, it's also for the RF hazard. The Red CA has a TGN, or a technical guidance note, for SAR testing and assessment guidance. And you can go to the Red CA's website and find that guidance note and follow that to determine how you would show compliance with the requirements for the Radio Equipment Directive and possibly the Low Voltage Directive, which also touches on RF exposure for safety. In summary, your evaluation is going to be determined by your use case of your device. Is it portable, mobile, fixed? The frequency is going to be determined if you need SAR, IPD, APD, different MPE requirements. Power device, the device is going to determine whether you're exempt or you need testing. And looking at all of these requirements while knowing that different countries have different limits. So you want to know where you're going with your device and what requirements are that where you have to comply, and be able to look at that on the onset to understand your exposure requirements, evaluation requirements. And that was a quick look at RF exposure. It is just fundamentals. So I'd be happy to attempt to answer any questions.
Thank you, Steve, for such a very informative webinar. So let's go ahead and check to see if we have any questions. I did see a handful of questions asking where we're going to get copies of the presentation or the recording link. So just to answer that in general, yes, you will get everyone who has registered. So obviously you guys also here on the webinar and in person will go ahead and get a copy of the presentation slides as well as the recording presentation itself. I usually do that. I normally need about 1 to 5 business days after the live event to go ahead and get that out to everyone. If you do not get it, please reach out to us at info@wll.com, and I'll put it in the chat when I'm done with asking questions to let me know you did not receive that. But again, yes, everyone will get a copy of the presentation slides as well as the recording presentation itself. So let me get to the questions. Let's see, we have how can consumers find information about the SAR levels of a specific device to make informed choices about RF exposure?
That's a good question. The RF exposure, the SAR values are to be published in the manual of the device, so that you can look at that. However, they have cautioned that just that number is not all inclusive to where it makes one device safer than another. It's just a way of looking at what their SAR values were. So there's more that goes into it than just the SAR values. I would start with that, but then there may be other information that's needed to determine if one was safer than the other.
All right, thank you for that. Next question. For RSS 103 exemptions threshold table in section 2.2, in section 6.2, is the value consistent for distance greater than 50 millimeters? I have an example like i.e. of 50 millimeters to 200 millimeters.
That's a good question. I have to actually look at that table in order to determine that, and I don't have that up right now. But if we'll capture that question and I'll get back to you on the specific answer for that.
All right, will do. I'll save that question and I'll throw it in the body of the email when I send out the presentation slides. That way everyone who might be interested in that question and the answer, you'll get it then. Next question. Can you explain RF exposure exemption limits for EU and France?
I have not had a chance to look into that. I do know that it's a different type of regime when you go to the EU. When you go to the EU, you're doing self-declaration. Manufacturer declares it's compliant. You have to comply with the standards, and because I don't do those tests often, I'm not. I'd have to go back and look, and I can answer that one again by email to determine any kind of exemption level. Offhand, I don't know of one. I just know that you have to comply with the requirements of the state that you do.
All right, next was not a question, but a great job, Steve, from a Greg Schumack. Next question we have is average cost of performing these measurements. By Washington Laboratories.
Washington Laboratories themselves, we do not do the SAR tests, but we do RF evaluation, exposure evaluations in order to work with compliance. But a lot of times that's on a case-by-case basis because we have to look at each product and determine whether there's multiple transmitters but it can go anywhere from 5K to, I don't know, if you're doing SAR tests, it certainly can be a lot more expensive than that, maybe 10 times. So it all depends upon what your evaluation requires. And again, it would be a case-by-case basis.
Okay, thank you. Next question. What is the general difference between IEEE 1528 and IEC 62209-1528?
I'm not aware of the differences between those. Um, the I'd have to investigate. I don't.
All right, not to worry, you guys. We will, I am jotting down the questions that will need a little bit more research, and we'll make sure we get those questions answered if we don't answer them today. Next question we have. Can you please brief us on the difference between the EN 62232, the 62311, and the EN 62479? All right, that's another one we will research. Probably what I'll do is gather all these questions and make it a separate document with the answers to them. So you'll get the attached with the presentation slide as well as the questions that are being asked today with the answers. Just requires a little bit more research, but thank you guys for your patience. Let me get to the next question. Someone did provide the email address. That's gonna be also captured, but I probably already have it in the registration, but if not, I'll compare it and make sure that that email also receives this presentation as well as the answered questions that need to be investigated or researched, excuse me. Next question. EPA not addressed. EPA analogy, hazard ID dose response, relationship exposure, assessment of risk. I guess they name a lot of different things. Characterization risk. This is EMC co-chair Annapolis.
Yeah, I mean, there's a lot of different things that we're not able to address in this very short presentation. It was geared more towards product certification for the FCC in Canada, their limits and their requirements. And I wasn't able to include that type of information.
All right, so again, this was just basically the fundamentals. It's a big topic to cover, especially in one day with 1 hour. But we'll definitely jot this comment down and maybe make another presentation. Take these ideas and make a presentation about each one of these. But thank you for that. Next question. I believe that IEC incorporated the IEEE doc. They were just letting us know that. Thank you, Greg. Next question, if the host manufacturer uses two pre-approved modules that both have SAR exemptions based on time averaging declaration, can the host manufacturer declare the exemption for the host product?
You're gonna have to look at that, the ratio. If both of those devices have exemptions, but they're only 70%, or they're at 70% of the requirement, then added together, those ratios would go over one, and therefore SAR would be required. It all has to do with that total ratio. So it's looking at the ratio of the compliant, how far below the exemption level each one of those devices is. And if they were both 40% of the exemption level, for example, then I believe you could do it, you could still be exempt. But as soon as that ratio goes above one, you no longer are exempt, and you would have to do the tests. Okay. All right. I think I'm working on it. For some reason.
All right, I think that is it for the questions. Again, if we did not answer your question or ask your question, you can always send an email to info@wll.com. It's right there on the screen. Also, send an email if you don't get a copy of this presentation along with the questions that were asked today and its answers. More like, give me till next Thursday of next week. If you don't get it, go ahead and send an email out. Email to that email address, and that'll be more of a reminder, or I can see why you did not get it. Again, thanks goes to Steve for such a very informative webinar. We would like to take the time to enlighten us about the RF exposure fundamentals. Thank you again, Steve. Our next upcoming webinar will be on cybersecurity. Next month on February 15th, starring yours truly, Mike Violette, the owner of Washington Laboratories. We will also have additional monthly webinars such as Japan radio regulations, Uniband and approvals, EU radio equipment directives, millimeter wave communications, as well as mill standards and much more. So please make sure you visit our website to subscribe to our Washington Labs Academy to receive updates. This is easily done by visiting www.wll.com. You click the training tab in the upper right corner, and you want to fill in your information where you see sign up for updates. Again, I just want to emphasize that if you have a different email than what you signed up for, put it in this chat. I'm capturing everything at the end of this webinar, and we'll get those questions answered for you. Again, on behalf of Washington Laboratories, we want to thank you for attending. We will now end this event and have a very great day. Thank you.